Let's talk about data type checking, and casting. In Kotlin, everything is an object. What it means is, for example, int and double are primitive data keywords in Java. They're not a class. However, in Kotlin, they are a class, and their properties are an object. In this code snippet, we have a property with int type. The value is 10, and because this property is a class, you can use its functions like minus. These are the data types available in Kotlin. As you can see, int, double, float, long, short, byte, character, boolean, string, any, unit, and nothing, and more. Let's look at some of the data types. Here is, I can say, the most popular data type, string type. In Kotlin, we have two types of string types: double quoted string and triple quoted string. Double quoted strings are so called escaped strings. Triple quoted strings are so called raw strings. If a string is surrounded by triple quotes, enter, spaces, or tabs inside the string will show exactly as we typed. So if you need a string with multiple lines, triple quote is what you're looking for. In addition, in Kotlin, strings can have variables in it. It's called a template expression with dollar symbol. Let's test it out. Here's the string variable. It's very typical string with a double quotes. And if we need multiple lines, you can do it with triple quotes. Let's add a new variable called data2 with the triple quotes. Let's type hello and enter world and enter, and let's add the variable 2. Like I said earlier, the triple quoted string will keep enters and spaces exactly the way we typed. Let's print out. As you can see down below, enters and tabs show exactly as we typed. The variable we put into also shows its value. Next, let's talk about any type. We already talked about that int and double are a class. In Kotlin, any type is the top level class. So any data type's superclass is any type, including int and double. And every data type can be casted to any type. Look at this sample code. We have data1 and data2 variables, and both are any type. As you can see, 10 and hello, which are int type and string type, is set to any type. Because any type is top level class, it's no problem. Next is unit type. Generally, unit type is used when there is no return value. It's very similar to void in Java. However, technically, there is a slight difference between two. In Java, void is a keyword. It represents there is no return value. On the other hand, in Kotlin, unit is a data type, not a keyword. So we can use unit type in the same way we use other data types. But like I said, generally we use it when we have no return value. In this code snippet, if you don't write a return data type, Kotlin infers that the return type is a unit type. Like the second function here, you can also write unit for the return type. Let's test it out. Let's add a new function. Like this, you can omit a return type, or you can write it explicitly. We're not going to write a return value in this function. That's what unit type all about. It looks very close to Java's void. However, like I mentioned, there's a difference. Let's say we're going to get the return value from this function. It looks a little bit strange because I said there's no return value. Even though there's no return value in this function, technically it'll return a unique type as a return value. Let's print out the return value. As you can see, exactly unique type is the return value. Next is nothing type. If we have nothing as a return type, it represents there is no return value. Like this sample code snippet, there is only exception in the function, no return. Next, let's talk about type checking. Kotlin has is operator for type checking. If you use the is operator to check types, Kotlin will automatically cast the type. It's so-called smart casting. Let's see the following sample. The function's parameter type is any type, and in the if condition, it's checking if the type is string type. If the parameter is a string type, it'll be casted from any type to a string type automatically without any casting code. Of course, there's a negative operator, not is. And here's a sample snippet, and we used not is to check types. Next, typecasting. Kotlin doesn't support implicit conversion for number data types. So the following sample code has an error. Int type can't become double type automatically. In order to do so, we are going to use the typecasting functions. As you can see here, if we need to cast int type to double type, we should use the toDouble function. These are the casting functions that Kotlin provides. In case of class inheritance casting, we are going to use as operator. Casting from a lower class to a upper class, smart casting kicks in. However, casting from an upper class to a lower class usually causes an error, except in case a lower class becomes upper class for a while and is casted back to the original lower class. Typecasting works exactly the same as in Java. Only the difference is Kotlin uses the as operator. This is it for the data types.